All right, we are basically done with our master material, our landscape master material. But one thing I would like to add is the RVT, the runtime virtual texture support. So this has two benefits. It's saving you a lot of performance because the virtual texture is like everything we don't really see, which is like far away, is not really being processed. So we save a lot of VRAM regarding our landscape. So especially when you have big landscapes like this, then of course you want to have this, and you want to save performance. Also, the next benefit for that would be we can later also use the height information of the landscape. And this gives us the possibility to also blend objects, like blend meshes into our landscape. I'm not really sure if we will implement this later when we build our scene, because as I told you, this is not only about creating a landscape material. This whole course is about having a master material for the start. You can use it universally for all your projects in the future. Make it a heavy tool with all the functions you need. This is just a part of the course. The rest of the course is like how you can make foliage trees, cinematic lighting, put everything together. How can you implement PCG to scatter your trees and meshes you want to have scattered in your landscape, and also just basically like all the stuff you need in order to create really nice cinematic environments. So the only thing I might leave out for now is the nanite tessellation. So it is the displacement. The reason why I leave out the tessellation, even though many people are like, yeah, I really want to have nanite enabled and tessellation enabled and all that stuff. Okay, first of all, it's not really that hard to enable nanite tessellation. The thing is, we already have the displacement information. We can already use the displacement information. So we have the displacement texture already enabled. And we can use it also for tessellation. So we just need to convert our landscape into a nanite landscape. You need to build the information, and then you basically have nanite enabled. So it's not really hard to do that. But the problem is it has still too many bugs. It's not really safe to use. It leads to many, many problems later on, and this is the reason why I'm not really enabling tessellation. But as a substitute, which is a really, really great substitute, is the parallax occlusion. So if you really, really count on like having nanite tessellation, I might just gonna add this feature maybe as a bonus episode in the future when the course has many students who are interested. I will just add this as a bonus. But as I said, it's not really hard to implement. It's not really a big deal, I should say. Of course, there are a couple of things you have to check. So of course we have to connect the displacement input also for each layer we have and all that stuff. But the landscape material is already a really heavyweight. It's complete. It has all the good stuff in it. And the good thing about that is not only that it has so many tools, but it's safe to use. It's relatively bug-free. I mean, you can always find a bug, of course. You can just swap all your textures without any breaking a sweat. Just replace all the textures you want. Just apply it on your landscape, boom, you're done. Slope, everything's perfect. Hook up the parallax occlusion mapping, boom. You have albedo controls, full albedo controls with all the parameters. You have full AO controls, specular controls with Fresnel. You add the tiling, everything, near and far distance. So this is pretty good. But just to finish this landscape material for you to use universally, I want to show you how to enable the runtime virtual texture support. So the runtime virtual texture support is not only for the material we have, our landscape material, and also for our functions which are inside our material, but virtual texture you need to enable in your project settings. And so every time you use this material, you will have the logic, the RVT, in your material function. So this is what we're going to do now. But you have to keep in mind, if you just hook this master material if you migrate this to your project, feel free to do it. It's pretty easy. Just get the material, migrate this to your new project, just boom. All the material functions, the master, the material instance, everything is already connected to that, and everything gets migrated, and it works out of the box. But for the RVT, this is something you always have to enable in your project. And you have to also build this inside your project. So you have to do things inside your landscape in order to have this working properly. So first thing you need to do when you have a new project, or in this case, you just use your project you have already, you need to enable inside your project settings the so-called runtime virtual. You have to enable the virtual texture support. All right. But in this case, enable virtual texture on texture import, no. And as for the opacity mask, you can also just disable that. So everything else, you can just leave it like so. And so this is the first step you always have to enable. So, and for my preference, I don't want to have the virtual texture on my imports. So I'm just disabling this and also the opacity mask. So once we did that, we can just restart now. Okay, and we're back. Just a quick tip. So I just enabled the runtime virtual texture support. So what I strongly advise you to do every time you open up your project, I mean, you can also put this into your default engine .ini data file in documents, but I strongly advise you to always get this command here, r.streaming.poolsize, and put this to 6,000 or maybe even 8,000. And just to make sure that we don't get a blurry textures. So this is like one thing you have to do. And also there's a command, I mean, yeah, if just in case, instead of using virtual shadow maps, so we are using virtual shadow maps, we are not using ray traced shadows. If you decide to enable ray traced shadows instead of virtual shadow maps, so this will be replaced. If you use that, you're going to have problems with all the nanite meshes. Also, when you convert this to a nanite landscape for tessellation, for displacement, you're going to have a problem. Just when you get rid of those shadow spots, just in case if you have this and you're using nanite meshes, there's something called two-sided geometry. r.raytracing.shadows enable two-sided geometry. You can click on this one and then spacebar 1 and then enter. If you use this command, I'm not using this because I would be stupid, I'm not using that, and we shouldn't for this course here. This is just a way on how to, this is just something you have to apply when you use ray traced shadows. Just keep in mind, okay? So those two console commands are pretty important, especially like the first one always, but the second one I just showed you is really important. Get rid of shadow artifacts and like shadow glitches, because a nanite is just too stupid to show the actual shadows on its surface. So this is why we have to enable the two-sided geometry. So now we need to go into our landscape material, so our master material here. We have enabled virtual texture support, so it is enabled. What we can do now, we disconnect this one, and we cache this layer logic, and we call this one layers. Okay, so this is nothing new, you know this already, pretty simple stuff. And then let's make some space. Let's put it here. We need to get our new cache, which is the layers here inside our material functions. Okay. From there, we need to get material attributes. So just get this one. And we need a couple of textures. You might have guessed this already. So get 5 textures. So base color is good. And then we get the specular on top. We get roughness. We get normal. And I think this is already enough. We don't need ambient occlusion for this. So just delete this one. So base color, specular, roughness, and normal. So this is pretty cool. And then we need a node called runtime virtual texture output. Okay? This one. And this is pretty self-explanatory. Just connect those things. As for the world height and all that stuff, this is something we take care later. We don't need to do this now. Okay, so just apply and save. Next step would be the world height. So for this, we get the world position. So this is called actually the absolute world position, but just type in world position, otherwise you will not find it. And we get only the height. So the blue channel is like the up and down axis. So the z-axis or z-axis, the blue channel. And we connect this to the world height. So we have the information about basically the height. As for the opacity, you can just get a constant. So right click. We don't need to change anything here. We just get a constant and set this to 1. Just in case if you're wondering what's the difference between a parameter and a constant. A parameter is basically the same stuff. You can type in a value. Later in your material instance, you can drag up and down a value, but the constant is something which will not allow you to use it in your material instance. It's hard coded. It's a fixed value you have inside your material, so this will not be visible in your material instance. Once you get a parameter, for example, like a vector parameter or maybe like a scalar parameter, this one. Once you have this, it's the same stuff like this. The only difference, this is something you can change in your material instance later, because this will be visible. This is why it has a sort priority for your instance if you set up a material instance. And this one doesn't have that, okay? So it's the same thing. The only thing is constant is just something we don't need to change. So this is hard-coded, basically, just for people to understand the difference between a constant node and a scalar parameter. Okay, so now we have our RVT output. This is our base logic here. The next step would be to get the runtime virtual texture sample, okay? So let's just take care of this. When we click on that, you have a virtual texture here. So you can choose a virtual texture, but in order to have a virtual texture, we need to create one. So here, if you just click on that, you have a runtime virtual texture you can create. So just click on this here. And I would like to put this into landscape, and then here, let's create a new folder. Yeah, let's do it here. And we call this one RVT. Open that one up. And we just call this one RVT material. And save, or call it RVT, just for you to understand that you have this texture saved. So the reason why we are creating a virtual texture is because all the stuff we have, all the materials we have, are stored in this virtual realm. This is the only difference what we are doing now. We just put all the stuff which is like screwing up our VRAM in order to, when we have high resolution textures and a huge landscape, we just store it in this RVT, in this virtual texture pool, you can say. This is why we save ourselves a lot of performance. I shouldn't say a lot, but we save a good amount of performance. Then when we have that, we created this one here. So make sure this is assigned or applied, and then you can see here virtual texture content. You can already see there's also like the world height and all that stuff, but for now it's perfectly fine to have base color, normal, roughness, and specular. Okay. So now we have this one here, and now we finally can set material attributes. So we can set those RVT textures. And for that, we do need base color, specular, roughness, and normal. So just like we have here, this is the content we store, or we can store right now. And this means we need 4 materials, base color. This one is the specular, just swap that. And we can use the roughness, swap this as well, and metallic would be then normal, because, I mean, yeah, metallic doesn't make any sense. And then we can just hook this one up, specular, roughness, normal, all that stuff. And we can already get our landscape material, but before we hook this one up to our landscape material output, we get static switch parameter, not the static switch, but the static switch parameter. And we call this one enable RVT. So we either want to use it or we don't want to use it, okay? So this is the great thing about this course, that we can always enable things, disable things, and everything is going to work out of the box right away. Okay, let's just sort this priority here. I want to put this into features. So let's just type in features. So make sure it's exactly the same, the typing. And when we check our material instance, we check for the features. We do have 2 things here. Yeah, okay, this means we can just use the sort priority 2, 0, 1, and this would be 2. And if this is true, if we enable this, we are using the virtual texture, makes sense. And if not, you might have guessed it, we are using this one we already had before, the layer logic. So get the layers. If we disable the RVT in our material instance, it's false, and we will just continue to use what we had before. Okay, boom, and then we can hook this one up. And then again, queue that, and then let's apply and save. Now, there's that. Now let's minimize this, because we need to do something in our landscape, or on our landscape. For that, we get a runtime virtual texture volume, okay? Doesn't really matter if you choose this from all or volumes, doesn't really matter. So just get the runtime virtual texture into your content drawer here, or your outliner in this case. And now we need to do a couple of things. So first would be the bounds align actor. You can see here, this would be our landscape. So first, let's just pick actor from scene. This would be the landscape, okay? And then we choose our RVT material. We just created inside our material layers function. You remember that? We created in a folder, and we created this RVT material. And there is the base color, specular, roughness, and normal information we have stored, or we can store inside this RVT material. And then we set bounds, because you can see this is quite small, right? But the runtime virtual texture volumes, like it already states, volume means, okay, so how big is this thing, this actor? And we can just set the bounds, boom. And then you can see he is making a volume, a cage, like already perfectly aligned. And yeah, so this is basically it. For now, let's just save that and save here also. Okay, so now when we click on our landscape material here, the MI, when we open this one up again. You might have guessed that also, that we, of course, need to, you can see it here, we need to enable the RVT. Let me just put this one to a 3. Apply, save, because I want to have this. Let me just reopen that instance. A Fresnel. Oh my god. Okay, so where's the Fresnel? Let me just quickly open up the Fresnel. I'm really sorry. This is not really part now of this lecture here, but let me just fix this one. So this is the sort priority. This one. Sorry, feature. Okay. Let's put this to 1. Let's just apply and save the Fresnel. So I just change the parameter here. This switch, this boolean, use a Fresnel. I just changed this from 99 to 1. And if I see now it's perfect. Okay, so I just wanted to have this enable RVT on the bottom in our features. So this is perfectly fine for me. Now for the material instance here. So we set the bounds and all that stuff. So this is now connected to our RVT, but we need to enable the RVT. So let's just do this. Just enable both boxes here. And now we can see he's preparing the shaders, and what is now going to happen? Now, oh my god, it's all gone. We broke everything. This is it. Thanks for watching. And no, I'm just kidding. So in order to get this back, we have to go into the landscape here on the right hand side. So let me just close that. And yeah, just, okay, blah, blah, blah. And then just search for something called draw. And we want to draw in a virtual texture. So click on the plus, and you might have guessed this already. So we go into the RVT, we click on this one, or you can also just drag it, or you can click and then click on the arrow, which is maybe a little easier. Then let's just wait for a couple of seconds, and boom, your RVT is getting all our textures back. Pretty cool. So let me just save, because we are not done. Why should we? It would be so easy, right? But it is not. So we are basically halfway through. We have to add a couple more things. So now you think like, yeah, what is the problem? Everything's fine, everything's perfect, it looks so beautiful, everything's nice. I can show you what the problem is. Look at the texture. Where's the tiling? Where's our distance blend? It's not here. And it's looking weird. I mean, you can see those small little glitches. This is normal because we are using the runtime virtual texture. But our far and near tiling is not working anymore. So what we have to do is we need to go back into the whole function stack we have here. And you can remember that we had something called distance logic, right? So let me just search for distance logic, okay? This is not really going to work once we enable the runtime virtual texture support. The RVT, the runtime virtual texture, or the streaming stuff, basically. Sometimes I may just make my explanations just too complicated. So material, so we use a separate material function, and you might have guessed this is called distance logic and underscore RVT. Okay, so now we have the regular distance logic, but now we need to go inside our newly, freshly created distance logic RVT, and we have to set the logic for our RVT once it's enabled. Okay, so inside here, just to build our logic, we need to first get a node called view property. So you can see this is like field of view by default, but this is not really right. We need to choose the, or we need to select the virtual texture output level. And from there, from the property, we can drag from here, get a power, but just control swap this. Just press control and swap. Because for the base, we want to use a constant. And we can just double that. Just to sharpen our resolution. Put it like so. Just get this one, sorry for that. And boom, perfect. So in order to see our start fade distance and also the end fade distance, which is not like visible when we enable the RVT, I was just demonstrating this to you. We need to get a multiply node. Just press M and click. And for this, you can also get a constant. So this means that we have this logic here. So our texture output level, our RVT output. and we need to multiply this by 1000. Otherwise, this will not be enough, okay? We will not see our RVT. And then we can, from here, just click or like use the add node. You can also just get this by just press A and click. And here we get not a constant, but now we can add on our start fade distance on top. So let's just get a parameter. So scalar would make much more sense. Scalar, and we call this one RVT underscore. Or let me just make it like so, minus. Maybe this looks a little better, doesn't really matter. So for the start fade distance, and we can use default values, for example, like 15,000. And now to get the end fade distance for the RVT, we get a divide. So just press D and click, and then just hook this one up. And we can just copy this one if you want. But in this case, I just want to get also a scalar parameter and rename this to, or not rename, but in this case, this is the RVT end fade distance. Let me just put this maybe to something like 10,000 as default value, and this 20,000. I mean, this is something we have to change up depending on your landscape and all that stuff. Of course, you need to change this. This is the reason why we use a scalar parameter instead of a constant. One more thing I have to do, I forgot, sorry for that. I want to sneak something in between for the start fade distance. And this would be again a 1 minus, just to invert the value. So a bigger value means we have a longer start fade distance, or like the start fade distance would be, how should I say, far away. If we increase, and when we decrease, the start fade distance would be closer, depending on our viewport. So this is why we need a 1 minus. If you don't add this, it would be the other way around. We have a low value, but our start fade distance would be much far away, and vice versa. So this is why we use the 1 minus to make this useful. So before we can hook this one up here, we need one more thing, which is the first, let's clamp this just to be safe. Then we need a runtime virtual texture. I could already see that. Runtime virtual texture replace. Okay. So we hook this one up to our virtual texture output. And for the default, we just get a function input scalar. So let's just minimize this. We have a little more space. So this one would be our default distance logic. Okay. Yeah, like so. We just straighten this. Boom. And also that stuff here. Cue this. Good. Yes, and I said scalar, right? Why didn't I change that? I forgot. Of course, it's not a vector 3, it's a scalar. So you're probably thinking, yeah, finally I can put this into the output. Yeah, we could, but you know, we want to have a switch. So we can either use the runtime virtual texture for the distance, for the near and the far tiling, or we just use the default distance logic, this one here. All right. So this is why we need another node, and this is the virtual feature switch, virtual texture feature switch, this one. So all this RVT distance logic, right? We just created. We put this one into yes. So in this case, we want to use that. If not, we get our RVT, a static parameter, or like our static, our static switch parameter. And you remember when we opened up our landscape, we have this already, right? So we have this thingy. Let's just copy this. Let me put this one here to the left, and we can use that. Why not? It's the same stuff. So this means we can use this one. So our default, this one is disabled, so enable RVT is false. So we use our default distance logic here. But if we enable RVT, so if it's true, makes sense that we want to go this way, right? All this stuff. So we put this into the true. And one more thing, the texture switch here, we also want to use this one. So for our virtual texture switch, if this is no, this is pretty self-explanatory. Of course, we are just using our default distance blend. Cool. So let's just get those nodes here and press Q. And then we can also Q this again. Or let's just select those things and Q. Good. All right, let's apply and save. So last step, we only need to hook this one up. And of course, we also want to straighten this one here so it looks a little better. And we need to put this into our distance blend group, and we want to sort things. So let me just check the MI landscape. Distance logic. So we need to type in distance logic, and yeah, let's do that. So let's just select this and shift drag select this. And we put this into the distance logic, just type it correctly. The start would be 2, I guess, and this would be then 3. So, but in order to see those things, we need to connect this MF distance logic RVT. Of course, we need to connect this to our layers. So let's go to our MF layers. So I think we have this here, right? Yeah, the landscape layers. So we need to open this one up. And we have a material function called distance logic, right? Yes. So this is our distance logic inside here. We just cache this, so this is the same. Let's just make space. And now what you can do, we get our distance RVT, distance logic RVT, and we just put it in between. And then apply and save. So now the distance logic is going through, but now it's also just checking for this logic, right? So previously it was just the distance logic, and we cached this. And this goes into our perspective layers, right? But now, every time this is connected to our input of our layers, the distance, this is also getting calculated. So he's going here, right? What is this? And he's checking, oh, virtual texture. Do we use a virtual texture? Yes. In this case, if we have this switch on true. If not, then we just use the default one. So this. Okay, I hope this is understandable. Okay, so now let's just close that. So we have this distance logic RVT here. So just make sure that you have this, like so, right? You can see it here now. And didn't I save? Apply, save again. And we have it now here. So this is now in between. So now this is getting recognized. When we go to our landscape material, so we have this material enabled, this is perfect. Now let's enable the RVT, which is already, so we can see enable RVT is true. And why is this? RVT start and end, this is annoying. The start fade distance, let me just get back to, where is it? Start fade distance, MF distance logic, here. So why is this not sorted? Let me check the number. Sorry for that. It's pretty annoying. So start, yeah, okay. So let me put this to 0 and this, let me put to 1. Apply, and I think we're good to go. Yes, we are. Okay, sorry for that. So now let's just check if we enable the RVT now, the start and end fade distance. So this is what you have to enable once you enable the RVT. Now you can see the texture here, the tiling, and if I zoom out, boom, we're getting the big texture. Also here on the grass, small texture and bigger texture. So yeah, just play around with those values, maybe increase until you find something useful. Depends on your scene. So yeah, this is pretty sweet. So now we have also the start and end fade distance working. You just need to play with those values until you find something useful. But yeah, so as for the RVT, this should be it for now.